Log 3 equals 0.4771. Log 4 equals 0.6020. So what is log 0.12? Well, from the previous question, we noted that log 10 was equal to 1. And we said that basically, if we have, so log 10 of, say, 100, what is log 10 of 100? Well, basically, to undo the logarithm, you swing this up and hits the question mark in the air. So 100, see the 10 swing up, hit that in the air? So asking this question is the same as asking this question, because they're equivalent. So what power do you raise 10 to get to 100? You raise it to the power 2, so this value here is none other than 2. So with those thoughts in mind, the other thing I want to mention is the other property of logarithms that we didn't mention in the preceding question, was that log A over B. Now times you add, but divide you minus top take bottom with properties of logs. So divide you minus top take bottom. So here's the rule that we're probably going to need to use in the above problem. So with those thoughts in mind then, and what we've mentioned in the preceding question, let's have a look at this one then. So here we know that 3 times 4 is 12, but we've got this is 12 over 100. So this will equal to then, are we all happy that's 12 over 100? So we can write that as a fraction then. That's log of 12 over 100. Divide, you minus top take bottom. So this would equal then the log of the top number, log 12, minus the log of the bottom number, 100. Right, now log 12 we can write as 4 times 3. So we can do that, or 3 times 4, it doesn't matter which way round we write it. Put it in a bracket, more than one term, minus log of 100. So here we've got log 3, plus times you add, as in the preceding question. So that's log 3, plus log 4, times you add, minus log 100. So now let's tidy that up then, and see what we've got. So let's make a bit more room. So we've got log 3, which is 0.4771, plus log 4, which is 0.6020, and then minus log 100. And log 100, as we said before, had the value 2, so that's minus 2. So what have we got then? Well, we've got 0.4 and 0.6 is 1, so we can just add them up in our mind's eye. So that's 1.0771. But we haven't added on the O2, which is here. So this 7, because that's in that position, the third digit along, 1, 2, 3, this 7 changes to a 9. So I'm going to cheat there and just put a 9 in there. Minus 2. Now we just do the subtraction. So 1 take 2 is minus 1, so it's 0.791 take 1. So again, I'm going to do that in my head. That would be 0.8, won't it? 0.8, 0.9, sorry. That would be 0.92, 0, and then 9. So it's 9209 here, 0 point. So let me just put the 0 point in now, and we'll just double check it in a moment. So if we added these two up, 9209 plus 0.0791, can you see that the 79 here would be 999? And then when you added the 1 to the last digit, it would all go back to 1.0, which is what we wanted, because that's the one. It would be a minus, of course, that's better. So when you add them, you'll get up to 2, won't you? Yeah? Okay, that's fine. Minus, I'll better write it out a bit more properly here, 0.9209. That, so far, that's by far and away the hardest question, really, question 14.